Good evening, ladies and gentlemen. We're going to go through the How Much Will They Pay worksheet. Now, the important part of this kind of work is to figure out what you're starting with and what you have to increase or decrease by. So Marlon charges $100 to his Visa card. So this $100 is the principal amount. Basically, principal in this case just means initial or beginning. Now he's charging it to a Visa card with a 12% APR. APR stands for annual percentage rate. And annual means yearly. But let's talk about credit cards for a moment. Credit cards are not charged to you yearly. They're charged to you monthly. So this right here is going to kind of tip us off. The fact that we're looking at a charge on a credit card, and then this next question, how much total will you have to pay at the end of the month? This is giving us the clue that we really need to translate this yearly percentage rate into a monthly percentage rate. Now, what's really going on with this? Well, he charged an amount to his card. He hasn't paid it off yet. And as a result, the credit card company is going to charge him a certain amount of money to keep their money on loan. Because you don't just get money for free. A lot of people seem to think that plastic money isn't real money, that's like monopoly money, but that's not the case. And it can actually cost you a lot in the long run, as we'll see as we get into future activities. For right now, we just need to kind of focus on the basics of how do we actually do these calculations. So Marlon charged $100. That's his principal. Now he's going to be charged 12% of this yearly, but we need to turn this into monthly. So yearly to monthly, we're going from 12, and if we divide by 12, that's going to get us our monthly because there are 12 months in a year. So this is 12% divided by the 12 months, gives us our monthly percentage rate of 1%. Now, as I said in my last video, we can't just use this percent as is. All right, this percent sign has a mathematical meaning. You have to resolve that mathematical meaning back into the number in order to be able to use that number in any sort of operation. Now, this line right here in the percent sign is actually representing a division line. And these two dots that the percent signs always have are actually zeros. They represent the zeros that are part of the 100 that you were dividing by. That's its mathematical meaning. So in order to turn this back into a regular number, you have to take 1 divided by 100, and that gives you 0.01. That's the proportion of this $100 that Marlon's going to have to pay every month. Now, as the amount goes up, he would have to pay more and more and more, but we'll get to that in just a minute. So I need to take this proportion of 100. Now, of means multiplication, so I need to take the 100 times 0.01. This is going to calculate my interest. And the interest is basically what he's being charged here. Now, if you take this and you multiply it, so 100 times 0.01, that gives you $1. So he's being charged $1 for hanging on to their $100 for an extra month. Now the total balance, which is actually going to be your answer, how much he has to pay at the end of the month, is taking that initial $100 and adding on the interest. So the total balance at the end of this is $101. That's how much he owes now. So if he were to pay off his debt, he would have to pay $101 to wipe the slate clean. Now, if we go to this next one, we're going to be dealing with some different numbers. Similar setup, though. Frank charges $250 to his MasterCard with an 18% APR. So this time, The 250 is the principal amount, or the initial balance. So I'm going to put P next to this to kind of keep track of the fact that that's my principal. I don't want to use I for initial because I would much rather use I for something like interest. Now this percent right here, my 18% APR, I'm going to have to take that into this conversion of yearly into monthly, because we're dealing with a MasterCard, which means we're dealing with a credit card again. And it asks how much will he have to pay at the end of the month. So we have that monthly thing going again. So first I'm going to go yearly to monthly. That means I need to take my 18% and divide by 12. And let's see, 18 divided by 12 equals 1.5. So I'm looking at 1.5%, but once again, I have to make sure that I turn this back into a number I can actually use in a math operation. Percent has a mathematical meaning. It means divide by 100. So this is telling me 1.5 divided by 100 is actually the value of this number. So I take that 1.5, I divide it by the 100 that it says, and you get 0.015. You can use the trick of moving your decimal point backwards a couple of places in order to do this, but sometimes it's just easier to grab up your calculator, divide by the 100, and make sure that your decimal is in the right place. All right, so we have 0.015. This is, again, the proportion of our principal that Frank is going to have to pay every month that he is not going back and actually paying off this debt. So his principal balance was $250. He didn't pay it off. He has to pay an extra 0.015 of that amount. So if I multiply those, I'm going to get 250 times 0.015 gives me $3.75. So Frank is being charged $3.75 for holding on to MasterCard's $250 for an extra month. So now, instead of just paying $250 for whatever he bought, he's actually paying the $250 plus the 3.75. So now it cost him $253.75. Now, sometimes this is advantageous when you can't really afford what you were buying initially. For example, several years ago, my laptop decided to die right before parent-teacher conferences. This was before the school district gave us laptops. So I had to go out and I had to buy my own laptop immediately so that I would actually have technology to use at parent-teacher conferences. Well, I wasn't expecting that expense, and you better believe on a teacher's salary, I can't just go out and buy the caliber laptop I would normally try to buy. But I did have a credit card, so I gave myself a little bit of a loan with my credit card, but I did that because I knew I could actually pay it off at the end of the month. If you pay off your credit card at the end of the month in which you made the purchase, then you don't have to pay this APR. So it's really important to know how much money APR adds on to what you owe so that you can carefully consider whether or not you can let a debt ride or whether you really should pay it off immediately. That's one of the reasons why you're learning this. Now, let's take a look at this next one. All right, Rosie charges $80 on her American Express card with an APR of 9%. So again, this is my principal, the $80. And my APR is how I'm going to figure out my interest. So again, APR means yearly. And I'm asked how much will she owe at the end of the month, so I have to go to monthly. So I'm going to take that 9%, I'm going to divide it by 12, and that is going to give me 0.75%. Now, that percent sign is still in there. Even though this is a decimal, we still have to take it out of percent form and turn it back into a regular number. We have to resolve this mathematical meaning. So take that 0.75, divide it by 100, and you're going to get I believe it's 0.0075. It's kind of late, so I'm going to double check this, because I made a mistake yesterday and I don't want to make that same mistake again. Good. I had my decimal in the right place this time. There we go. Now this is the proportion of that $80 that she's going to have to pay. Now this isn't going to look very drastic because this is a very small proportion and that's a very small charge. So I'm going to take my $80 times my 0.0075, and that is going to equal, let's see, 80 times 0.0075 equals 0.6, so 60 cents. So my principal amount plus my interest equals the amount that I owe now. Now you may be wondering, isn't there a formula for calculating interest like this? Yes, there is. In the work we're going to be going into in the future, the formula is not going to help us as much, because what if we start making payments on this debt, but some of the debt is still there? That's a more complicated equation to write. So we're going to keep it kind of broken apart like this for a little bit because it's going to serve us better in our future activity. That's why I'm having you do this instead of blindly following a different formula. All right, so this is my total balance. That is my answer. So I'm going to box these answers in. Whoop. Cut off part of my answer there. Then we're going to go on to that last problem, because that last problem takes us through a couple of steps. All right, let's take a look at this last one. Marjorie has put $500 into a savings account that pays her 2% annual interest. How much will her $500 be worth after 1 month? How much will her $500 be worth after 2 months? After 3 months? So this is looking at a savings account that's paying her. So this isn't looking at what she's going to owe. This is looking at what she's going to have in the bank. That's a much nicer calculation to try to figure out. Again, her $500 is her principal. And you're looking at an annual interest rate, but we're looking at it being paid out monthly. So we have our $500. Let's turn this 2%. We again need to go yearly to monthly. So let's see, 2% divided by 12. Just 0.166, and that would keep repeating. Now that is still a percent, so I still have to divide by the 100. So let's see. It's going to equal 0.00167, let's say. And when you multiply this together, you can definitely tell it's late because I am typing things in a little funky. So we have 0.835. It's about 83 or 84 cents. Now, here's the thing. When you're dealing with a financial institution that's paying you, sometimes they don't round up. And they'll probably take it out a few more decimal places than we did, so they would be unlikely to round up. I'm going to give us the benefit of the doubt, and I'm going to let us round up. So our $500 plus the 84 cents that we just earned equals $500 and 84 cents. Now that's just month 1. Now here's the trick. For month 2, we need to be careful. We currently have what we had at the end of month 1 in the bank. That's what we're starting month 2 with. We're not starting with $500 anymore. We're starting with $500.84. That's what we need to take times 0.00167 in order to figure out our next interest payment. So 500.84 times 0.00167. And we have about 84 cents again. You can see it's gone up just a little bit, but it's not making a huge change. That's because the annual interest rate is so low. That's one of the reasons that people actually invest in the stock market instead of just putting things in a savings account. Savings accounts barely make any interest anymore. They used to be much better, but they don't make a lot. Mutual funds, money markets make a little bit more. Mutual funds tend to do a lot better, and they have a pretty decent spread on the market. All right, we can talk more about that in a little bit. So we are going to take our 0.84 that we have here, add that onto our previous amount, and our new balance is $501.68. Month 3, do the same sort of thing. But use the balance from the end of month 2. Because this is now the amount that we have in the bank at the beginning of month 3. Times our same multiplier, and 0.00167. We have about 84 cents again. It's gone up a little bit more, but still not enough for us to get a different rounding value. So we are at about 0.84 again. Let me actually write this number correctly. And don't be afraid of making mistakes like that. As you can see, I'm leaving any errors that I'm making directly in the video. Math is a process. It's not a precision instrument. You can't be afraid to make mistakes when you're doing math. It's a part of learning. And the key thing is to know how to double check your work, how to make sure that you're not making silly mistakes. Notice that I'm using the calculator to double check some of my division because I know I'm tired and I'm likely to make a mistake. As I'm going through this now, I'm making sure that I'm writing out my work so that I can double check and ensure that I have things written correctly. I'm going back and I'm rereading what I just wrote to make sure that it's actually accurate. Those are the kinds of things that you can do to make sure that you are being as accurate as you can while not holding yourself to an impossible standard. You're not going to be perfect all the time. I mean, heck, your teacher's not trying to be perfect all the time. So don't worry about those little mistakes. The key is to learn from them and work on figuring out ways to prevent them when possible and catch them as quickly as possible when you can't prevent them. All right, so $502.52 is what we have in the bank after 3 months. And that is the end of the How Much Will They Pay worksheet. All right, so definitely let me know in the question at the end of this if you have any additional questions and we can go through those. I hope this helped more so that we're able to continue on our remote learning journey. I will see you soon. Good night.